The most expensive bill a municipality has to pay is the electricity it consumes to clean its sewage. Large quantities of electricity are used to oxygenate the water and sustain the microorganisms that clean it. Eliminating the bacteria from the water is another costly process. Romanian researcher Olga Tiron and her team of experts developed a system that helps oxygenate the water using algae. The novelty of this project is the patented procedure of granulating the microalgae and bacteria together. These granules then settle to the bottom of the containers. The resulting water is clean and safe to be released into the environment. Stay tuned to understand more about this cost-effective technology that will soon be used to clean our wastewaters.
What is the primary goal of the GRAL recovery project in the field of wastewater treatment?
The primary goal of the GRAL recovery project is to answer to the problems facing operators of the water supply and sewage services. The idea is that we, as researchers in environmental biotechnology, we are focusing to solving different kinds of problems in the field of the environment and also bringing useful ideas to life. And for this reason, we are trying every time to be updated to the needs of our society and to answer to these needs, having the mission to keep the balance between society development and nature. And in this way was born GRAL recovery project. The reason is that each drop of water that we use in different kinds of activities, from householding to industries, must be returned safely, must be returned cleaned from where it was taken. Because we as humans on this planet facing, unfortunately, with limited available freshwater resources. And there are countries with big issues in this matter. Therefore, we must take care, we must be responsible of what we use and what we have. Of course, cleaning of the sewage water, also called as wastewater, is performed by wastewater treatment plants and has a technology applied in this regard, technology that was applied since almost 1 century ago. And indeed, at that time, we had less wastewater to treat and we didn't know very well about the impact of different kinds of technologies on the environment. And unfortunately now it was found that even if wastewater treatment plants play a critical service for human beings by cleaning the water and making it safe, unfortunately they have negative effects on the economy and on the environment. First of all, wastewater treatment plants requires a lot of energy because in fact wastewater is cleaned by milliards and milliards of bacteria that as humans need oxygen. And for this, operators of the wastewater treatment plants pumping intensively the air into the process, and this requires a lot of electricity. When municipalities receive the bills, the highest prices on that bills is linked to the water and sewage services. And this high cost represents, in fact, very serious problem because mainly due to this, almost 80% of wastewater resulting around the world, 80%, is just not cleaned at all. It's just returned into the ecosystems untreated. Because it becomes very challenging to keep the functionality of the wastewater treatment plant, especially by low-income countries or territories which are facing with limited available energy resources. In the second, this bacteria that we using for treating our water promotes a lot of greenhouse gases emissions. The concentrations of greenhouse gases emissions is so impressive that carbon dioxide concentration released after wastewater treatment processes around the world exceeded the carbon dioxide concentration released by entire Australian continent. So we are aware of reducing the carbon dioxide from car driving, but even if it is not intensively discussed on the media about wastewater treatment plants, we must be also aware to decrease the quantity of carbon dioxide from wastewater treatment plants. And in the third, all these bacteria that basically clean our water represents tons of unlimited waste, which mainly in Romania is landfill inside wastewater treatment plants, which have limited spaces for this. More than 75% of this waste generated continuously is just landfill. Therefore, I emphasize here three major problems that are concerning operators of water supply and sewage services, and definitely we need solutions in this case.
What are the sustainability aspects related to the GRAL project?
The GRAL recovery project presents the GRAL recovery technology, which is addressing to all problems outlined concerning the operators of the water supply and sewage services. The GRAL recovery technology relies on a patented method and involves the use of a microalgae, which in fact represent the second earliest life forms developed on Earth after bacteria, and which microalgae provide more than 50% of the oxygen on the Earth planet. What is interesting that at the beginning, oxygen gas was not at all on the Earth planet. This gas appeared once with the development of the microalgae, which began to generate the oxygen through photosynthesis by using sunlight. Taking this feature of the microalgae, instead of using fossil fuels to generate power, to generate electricity in order to pumping intensively the air in the wastewater treatment plants, we can use these living forms, microalgae, to obtain required oxygen by bacteria. Moreover, carbon dioxide, this dangerous greenhouse gas, represents in fact for microalgae breakfast, lunch and dinner. And against bacteria, if we will integrate the microalgae into wastewater treatment plants, we can increase the number of options for waste harnessing, because microalgae can be found everywhere and they are used as a raw material in a very wide range of industries.
So, what are the preliminary results of your research?
From the beginning, GRAL recovery project was foreseen as a complex and quite challenging project, because there are a lot of questions regarding the functionality of the GRAL recovery technology, long-term functionality, and whether this technology can ensure proper quality of the treated wastewater according to regulations. In other words, the question was if by using microalgae we can ensure the same treatment performance of the wastewater as in the case of bacteria, as in the case of conventional technology.
What is the novelty that your project brings into the scientific world?
The idea of using microalgae to treat the wastewater is not new. This idea was reported for the first time in the middle of the 20th century. But until now, performed research in this field encounters difficulties in emerging this technology outside laboratory border, mainly due to the one question. If we will try to use this microalgae to treat the wastewater, how we will remove this species from the liquor? Because in fact, microalgae are very small cells. They usually have 0.03 millimeters, and it becomes very expensive to recover them from water. We have here an example of culture of microalgae, which is used for wastewater treatment, as we can see, the liquor is green. So we cannot remove this treated effluent in the environment because it is not safe. And the research conducted with an Eco Institute allowed us to find a method, to find a solution to this problem, just using the same microalgae, but developed into granular structure, which allows us just to obtain clean water only by settling. And of course, this method allows us to go beyond laboratory border with the technology.
What are the upcoming steps in your project?
At this moment, the GRAL recovery project is in the final stage of implementation. But gathering until now results, we are focusing now to develop a new step for this technology by targeting technology deployment involving directly the operators of the water supply and sewage services along with business community.
Working with a diverse team and collaborating internationally with esteemed institutions like Norwegian Institute for Bioeconomy Research, Norwegian University of Life Sciences and Wallachia University of Târgoviște. What advantages or benefits does this partnership bring to your project and your team?
Definitely the collaboration with Norwegian partners play a significant role in the GRAL recovery technology development. With the support of the Norwegian Institute of Bioeconomy Research, NIBIO, it was possible to implement for the first time the ground recovery technology outside Romanian borders and to increase the value of the waste resulting after wastewater treatment process. Also, in this project, we targeted to integrate the technology inside economy sector by identifying useful applications of the resulting waste. And in this regard, our project partner, University Valahia of Târgoviște, tried to promote to market, in collaboration with a private company, the microalgae biomass, the resulting microalgae biomass, by manufacturing biodegradable plastic materials, along with the production of the photovoltaic cells, which can be used for obtaining solar panels. Overall, after 4 years, almost 4 years of research, definitely this performed research increased the expertise of each partner and making possible to identify new research directions by making, in fact, the end of the ground recovery project the beginning of more complex and challenging period by increasing the self-confidence of this technology, the impact of this technology on the fields of wastewater treatment and harnessing of renewable resources, because microalgae is a renewable resources.
In conclusion, for the people who watch this interview, what would you like them to remember about your project?
Taking the opportunity of this question, I would like to point out that ground recovery project promotes an alternative nature-based solution to treat continuously resulting municipal wastewater according to legislation, but in the same time providing less economic and environmental impact. We are inviting all operators, market players, any person which is interested in the wastewater treatment sector or microalgae biotechnology sector to discover more on the project website at groundrecovery.com, to contact us for more details and to join us in order to develop and harnessing this technology beyond laboratory border. And we will just enjoy to increase the team which is working on the ground recovery technology.
Thank you for watching Research in the Spotlight, a podcast for scientists and passionate science people made under the Norway Grants research program by the Executive Agency for Higher Education, Research, Development and Innovation Funding as program operator. Until the next time, like and share this episode if you think science is a key to a better future.